Hello everyone. Today I am solving this problem arithmetic slices, and in this problem we are given an array of integers and we are required to tell whether how many arithmetic slices are there in the given array. So what is the meaning of arithmetic sequence? Let us first try to understand that. Well, suppose we have a sequence of integers 2, 4, 6, 8 and 10. Then this sequence is called arithmetic if it follows two properties. The first one being that it must have at least three elements, which this sequence definitely pass because it has five elements, which is definitely more than three. And the second condition is that the difference between any two consecutive element needs to be the same. This means that if I pick these two consecutive elements, then the difference between them, as I can see, is 2, and let us pick these two consecutive elements, then the difference between these two elements is 2 as well. Now let us try this on the sequence 6, 7, 9, 10. So now is this sequence arithmetic? Well, this sequence also passes the first property, that it has minimum of 3 elements. The second property is not going to get passed because the difference between these two elements is 1. The difference between these two consecutive elements is also 1, but the difference between these two consecutive elements is not 1, it is 2, and therefore this sequence is not arithmetic. So now we are actually required to tell that in the given array how many arithmetic slices or how many arithmetic subarrays are there. So for example, if I have 1, 2, 3, 4, 5, in this case let us try to count simply by brute force how many arithmetic subarrays are there. So definitely this is an arithmetic subarray. Then from 2 to 4 is also an arithmetic slice because 2 and then 3 and then 4, these have minimum of 3 elements. They have 3 elements, and also difference between consecutive elements is also 1. Similarly, this is also an arithmetic slice, and then 1, 2, 3, 4 is another, and then 2, 3, 4, 5, and then finally 1, 2, 3, 4, 5. So this has a total of 6 arithmetic slices. Similarly, we can also have an array where difference between any two consecutive elements is not same. For example, 1, 4, 7, 9, 10, 11. Now in this case, the difference between 1 and 4 is 3, and 4 and 7 is also 3. Therefore, this definitely is an AS. Let us call this thing AS. And 479. Now here 479 is not an AS because the difference between these two elements is 3 and these two is 2. Then 7, 9 and 10, no luck there also. And then 9, 10, 11 is definitely an AS. So here we have two arithmetic slices, if I am correct. So that's the answer for this array, and this is the answer if this array is given. So how this problem can be solved? Now let us take another array 1, 2, 3, 4, 7 and then 10, and finally let us take one more element 11. There is one little observation that if we have 4 consecutive elements, let us call them A and then B and then C and then D. Now if we have 4 consecutive elements, how many slices are we going to have which are arithmetic? Well, as we already know that arithmetic slice have a minimum of 3 elements, so ABC is one slice, BCD is also one slice, and ABCD is the third slice. And if we have then ABC, BCD, then CDE, then ABCD, BCDE, and finally ABCDE. So this is how the progression goes for slices when we have consecutive elements with equal difference. So now if I know that I have a sequence whose difference of any two consecutive element is equal to the difference of any other two consecutive elements, in that case I can actually simulate this process, and by formula I can actually calculate how many valid slices are there. So when the slice length is 3, it can actually start from the first element and it can move up to at most C. If the length is 4, then it can start from A and it will only move up to B, and if its length is 5, then it will only start at A, and this is going to be the last possible slice of length 5 as well. As you can see that when the length chosen is 5 or when the length of the slice is 5, there is only one possible case, so 1, and when there is a length of 4, then there are two possible slices, and when the length of the slice is 3, there are three possible cases, that is A and then B, from B to D and then from C to E. So similarly, this keeps on going, and if again I increase the number of consecutive elements whose difference is same than A, B, C, D, E, F, the slice with length 6 is going to be only one, with length 5 we will have two slices, and so on. So if you can see this actually, then what is actually happening is total number of elements in the array minus 2, that is there are 5 elements in this array, and if I subtract 2 then I'll have 3. Then we have the formula n plus 1 by 2, and if I plug n is equals to 3 in this formula, then I'm going to get 6 actually, which is indeed the case that there are 6 possible slices. And this is very logical, that if we have 5 elements then 1, and then if we consider all the slices of length 4, then I'll have 2 such slices, and if the length of slices is 3, then I'll have 3 such slices, and in fact if I consider the slices of length 4, I'll have 4 such slices, and if I consider the slices of length 1, I'll have 5 such slices, that is for 5 elements. But that's the thing, that in our problem an arithmetic slice must have at least 3 elements, and therefore there is no point in actually considering a slice of length 2 or 3, so I'm going to remove this. So all that we are left with is length of the array minus 2, which is this, and then summation up to that point, that is 1 plus 2 plus 3, which comes from this formula. So this is a very small observation to solve this problem. So now how we are going to use this fact in order to solve this problem? Let us try to simulate this problem for this case as well. Again, I'll start from 1, and no, I'll actually store the difference between these two elements, and it is 1, right? So let us assume that currently count is 0, and let us also say that we have another variable answer. This is the actual answer, while count is something which tells us how many elements are there currently in our slice. And I am already assuming that I have 2 elements in the slice, but still I am taking count to be 0. And the reason is very simple, that when I move to, because after all I need to subtract 2 from the count, so rather than subtracting 2 afterwards, I'm actually starting from 0 when I'm actually at the third element. So when I came to this element, I see that the difference between this element and the previous element is actually 1, which is equal to the chosen difference, that is not the chosen difference but the difference between first two elements, and therefore I'll increase the value of count by 1. Again I'll move forward to the next element, and again the difference between this element and the last element is equal to the taken difference, which was 1, and therefore count is going to get increased by 1, therefore it will become 2. And then again I'll move forward. Now this time, as you can see, that 7 minus 4 is not equal to the difference between these first two elements. And how many slices we have? We have 2 multiplied by 2 plus 1 by 2, which is 3, and which is true because the first slice is 1 to 3, second slice is 2 to 4, and third slice is 1 to 4. So this count actually tells us the total number of elements in the subarray or in the considered subarray minus 2. So this is what count actually is. Now again I set count equals to 0. Again I am choosing 4 and 7 to be the first and second element of the current subarray, and therefore difference is 7 minus 4, which is equal to 3, and I am going to move forward. And yes, I also need to increase the value of answer, which was previously 0 is now set to 3. Now when I move forward and I see that the difference between 10 and 7 is also 3, I can increase the value of count by 1, and again I'll move forward only to realize this, that now the difference between this element and the previous element is not equal to the difference of the first two elements of the array, and therefore at max we have this slice 4, 7, 10, which is definitely valid. And yes, 1 multiplied by 1 plus 1 divided by 2, that is our formula, is definitely states, therefore answer becomes equal to 4. So in total we have 4 slices, and again in the last pass what I am going to consider as the new difference to be 1, that is 11 minus 10, 1. But now there are no further elements to check, and therefore count will remain equal to 0, and finally I'll only add 0 multiplied by 1 divided by 2, which is equal to 0. So the value of answer is not going to change and it will remain equal to 4, and this is indeed true. So this is a linear method to solve this problem, and in this case the time complexity is going to be only of order of n, which is perfectly fine. So now let us try to solve this question. Now first case is definitely when the number of elements in the given array is less than 3. In this case we definitely know that there are no possible arithmetic slices, and then I'll return 0 only, and therefore an int is equals to a dot size, and if n is less than 3 then return 0. Otherwise, as I told you that we need to first choose the difference, and therefore difference is equal to a of 1 minus a of 0, that is the difference between first two elements, and I'll start from the third element till the end, and if the difference between current element minus the previous element is equal to the taken difference, in that case I need to increase the value of count by 1. Otherwise I am going to increase the value of answer by count multiplied by count plus 1 divided by 2, and again I'll set count is equals to 0, and this time difference is going to be equal to a of I, that is current element, minus previous element, like this. And I definitely need two more variables. One is in count, which is equal to 0, and the variable answer, which is also initially equal to 0. Finally, when I am actually out of this loop, I again need to increase the value of answer by count, and then I'll return answer. Now one thing that you may not understand is this, whether why I am increasing the value of answer after the loop. The reason is simple, that there is a possibility, suppose that this is our array 1, 2, 3, 4 and then 5, and in this case I'll move forward one by one, and then when finally I am here, the difference between these two elements is 1, which is also the difference between the first two elements, and therefore I will actually never encounter this part of the conditional statement else, because difference is always going to be equal to the taken difference. And this is precisely the reason why, even if I am out of this loop, even if I have passed all the elements, the current number of count need to be used to actually increase the value of answer, and then finally I am returning that answer. So that's how you can solve this problem, and now it's time to submit. So I'll run the code and accept it, and then I'll submit, accept it. So that's how you solve this problem, and that's it for this video. I'll see you in the next one. Thank you.